Today we will see two results and few important problems. Actually that is exercise 10.3. Simple problems, but it is important. Actually you can solve those problems. Okay. Let us start with this one. For any two vectors A vector and B vector, we always have a magnitude of a dot product. A vector dot B vector is always less than or equal to magnitude of A vector into magnitude of B vector. This is called the Cauchy squares inequality. Okay, we'll prove this one. See, the condition is given: magnitude of A vector dot B vector is less than or equal to magnitude of A vector, magnitude of B vector. Now, see here, if it is either A vector is equal to 0 or B vector is equal to 0, okay, if it is A vector or B vector is equal to 0, then obviously this condition holds, right? So A vector will be, this will get as 0. So this will be now magnitude of A vector dot B vector will be equal to 0. That equal to magnitude of A vector, magnitude of B vector. Right? If it is any one vector, either A vector or B vector is equal to 0, then the product of this will be 0, and here if you multiply by B vector or A vector by 0, then it will be equal to 0. In the case of A vector is equal to 0 or B vector is equal to 0. If we consider, let us consider A vector is not equal to 0 and B vector is also not equal to 0. Now, if it is these two vectors are not equal to 0, then we will prove this one. Okay, if it is equal to 0, then equality holds. Not less than, equality holds. If it is not equal to 0, see here we have the formula. A vector dot B vector is given by magnitude of A vector, magnitude of B vector into cos theta. Right? By this we can write A vector dot B vector divided by cos theta formula, magnitude of A vector, magnitude of B vector is equal to cos theta. Directly you can write this formula. Now we will take mod on both sides. If I take mod on both sides, this will be magnitude of A vector dot B vector divided by magnitude of A vector, mod of that will be again mod B vector is equal to mod cos theta. Now can you say what is the value of mod cos theta? What is the range of cos function? It is between -1 to 1, right? Cos theta function is between -1 to 1. So here modulus is there. Obviously this will be less than or equal to 1, right? The range of a cos function is between -1 to 1. If I take mod, then it will be 0 to 1, right? Either equal to 1 or less than 1 possible, right? So mod of A vector dot B vector divided by mod A vector, mod B vector will be less than or equal to 1, right? By using this one, we can write this as magnitude of A vector dot B vector is, if you multiply by this, less than or equal to magnitude of A vector into magnitude of B vector. So this is clear. Magnitude of dot product of a two vector is always less than or equal to magnitude of A vector into magnitude of B vector. This is called the Cauchy squares inequality. I hope you understood this. Let us move to this one. See here, this is another result. For any two vectors, A vector and B vector, we always have magnitude of A vector plus B vector is always less than or equal to magnitude of A vector plus magnitude of B vector, triangle inequality. This is called the triangle inequality. Okay, let us start with this. See, let me consider. This is one A, B, okay, line and a vector. A, B vector will represent this as A vector, okay. Then B to C will consider as B vector. Now by using a triangle, AB vector, BC vector. So AC vector will be sum of these, right? AC vector is equal to AB vector plus BC vector, triangle. So this will be A vector plus B vector. Clear? Now we will consider this. Now let me consider magnitude of A vector plus B vector square. Okay? Magnitude of, we have to prove this. For this we will consider magnitude of A vector plus B vector whole square. I can write this as, see, A vector plus B vector dot A vector plus B vector. square can be written as x vector dot x vector. So similarly, magnitude of a vector plus b vector square can be written as a vector plus b vector dot a vector plus b vector. Now we will apply a dot product here. A vector dot a vector, right? We are multiplying a vector dot a vector plus a vector dot b vector. Next you have to multiply by b. So this will be b vector dot a vector, right? Plus b vector dot b vector. Clear? Now see, a vector dot a vector will be magnitude of a vector square. Now you know that this vector will be commuted to Lahore's here, right? So a vector dot b vector plus b vector dot a vector. So you can consider b vector dot a vector as a vector dot b vector. Both are same. So we can write this as plus 2 a vector dot b vector. Adding these two. Okay. Now b vector dot b vector will be plus magnitude of b vector square. Okay. Now can we write this as less than or equal to magnitude of a vector square, okay, plus 2 magnitude of a vector dot b vector plus magnitude of b vector square. Can we write like this? See, actually a vector plus b vector magnitude whole square is equal to this one. Now by using this one, see here, a vector dot b vector is there. So this one written as less than or equal to 2 magnitude of a vector dot b vector. For example, see, if you consider any value, if I consider x value is always less than or equal to mod x, agree? X is always less than or equal to mod x. Consider any value. If I consider minus 6 is less than or equal to mod of minus 6 will be 6. Yes, true, right? Minus 6 is less than 6. If I consider plus 6, so 6 is less than or equal to 6. So here equality holds. So x is always less than or equal to mod x. It can't be more than that. Either that should be equal to that or less than mod x. So by using that condition, we can write here a vector dot b vector. This is a one scalar, right? A vector dot b vector is always less than or equal to mod of a vector or magnitude of a vector dot b vector. Is it clear? So a vector dot b vector can be written as less than or equal to, this is as it is. Here we have considered the mod and this is as it is. Now see this one. Now again this can be written as less than or equal to magnitude of a vector square plus 2 into, what about magnitude of a vector dot b vector? Here we prove magnitude of a vector dot b vector is always less than or equal to magnitude of a vector into magnitude of b vector, right? So here we can write this as less than or equal to. So this value is less than or equal to into magnitude of a vector into magnitude of b vector. I hope you are understanding this one. By using this, I will consider this as star. Okay, by using star. Here, right? By using star. Now again last term is as it is plus magnitude of b vector square. Now it's of the form a square plus 2ab plus b square. Right? I can write as a plus b whole square. So this can be written as magnitude of a vector plus magnitude of b vector whole square. Right? So by that what we got? Magnitude of a vector plus magnitude of a vector plus b vector whole square is less than or equal. This is a symbol, less than or equal to magnitude of a vector plus magnitude of b vector whole square. By square, taking square on both sides, square root on both sides, square here will get cancelled. So by this we can write magnitude of a vector plus b vector is always less than or equal to magnitude of a vector plus magnitude of b vector. So this is an important result. Okay, we proved this magnitude of a vector plus b vector less than or equal to magnitude of a vector plus magnitude of b vector. Now if it is equal, what happens? See, let's see the next condition. Suppose, see the condition is given, listen carefully, important one, this is also. A vector plus B vector is always less than or equal to magnitude of A vector plus magnitude of B vector, right? So this is given. If it is equality holds, that is magnitude of A vector plus B vector is equal to magnitude of A vector plus magnitude of B vector. What is mean by this? A vector plus B vector. A vector plus B vector will be equal to A vector, right? So I can write as AC vector, that is magnitude of AC vector, right? A vector plus B vector. This is equal to A vector. What is A vector? AB vector, that is magnitude of AB vector plus B vector will be BC vector. So this will be now plus BC vector. Now see here, magnitude of AC vector is equal to magnitude of AB vector plus BC vector. Let me consider AC vector. So this is the AC vector, right? So this is the AC vector. Now this is equal to AB plus BC. Where I have to take the point B? Is it possible to take outside the line? No, right? AB plus BC. A to B plus B to C. The point should be on the line, right? If I consider point here B, right? The point should be on the line. So I can write AB plus BC, right? So whenever this equality holds, then we can say that the 3 points, I mean A, B, C are collinear, or we can say A vector, B vector and those lines will be collinear. So we can say that here the points, if it is equality holds, important ones to solve the problems, the points A, B, C, I mean A, B, C, those 3 points A, B, C are collinear, I mean they are in a same line. Collinear. Now we will see some problems. 3 points are given. A, B, C are collinear. To prove this one, we will use the previous result. What you have to do? You need to find the vectors first. First find the AB vector, then find BC vector, then find either AC vector or CA vector. After finding that, you have to show that magnitude of one vector is equal to sum of the magnitude of two vectors, right? Then we can say that these 3 points we have solved. Magnitude of A vector plus B vector is equal to magnitude of A vector plus magnitude of B vector. By this we can say that those 3 points are collinear. Let us do this. First I will write AB vector. How to find AB vector? Vector joining 2 points, right? So this is 1 minus of minus 2 will be plus 2. So 1 plus 2 will be 3 I cap. Okay. Better you write that. First write B, then write A, then subtract. Okay, do that. Now 2 minus 3. 2 minus 3 will be minus 1 J cap. 3 minus 5 will be minus 2 K cap. AB vector. Now we will find BC vector. Okay. BC vector we have to start with C. So 7 minus 1 will be 6 I cap minus 1. Sorry, here J is not there, right? So 0 minus 2 J cap. So it will be minus 2 J cap. Next minus 1 minus 3 K cap. It will be minus 4 K cap. Next we will find AC or CA. Anyway, we are finding the magnitude, no problem. So if I find AC, so this is now 7 minus of minus 2 will be plus 2. So that will be 9 I cap. And here J is not there. So 0 minus 3 J cap. So it will be minus 3 J cap. Then minus 1 and minus 5 K cap will be 6 K cap. So clear? We got 3. Now we have to find the magnitude. Magnitude of AB vector is equal to 3 square will be 9 plus 1, 2 square is 4. So this is equal to root 14. Right? Next, BC vector, magnitude of this is equal to root of 6 square is 36 plus 2 square is 4 plus 4 square is 16. So 16, 20, 20, 56, right? Root of 56. Root of 56 can be written as, I can write this as 14 into 4, right? 14 into 4, square root of 4 will be, it is root 14, right? So AC vector, so AC vector is equal to square root of 9 square is 81 plus 3 square is 9 plus 6 square is 36. So this is equal to root of 3. 81 plus 9 will be 90. 90 plus 36 will be 126, right? So we can write 126 as 14 into 9. So 14 into 9 means square root of 9 will be 3. So this is equal to 3 root 14. So here you can see this 3 root 14 is equal to 2 root 14 plus 14. It will be equal to 3 root 14. So by this we can write magnitude of AC vector is equal to magnitude of AB vector plus magnitude of BC vector, that is 3 root 14 is equal to root 14 plus 2 root 14. Therefore 3 points ABC are conical. I hope you understood this important one. Just find the vectors, then find the magnitude of those and check sum of the two vectors. Sum of the magnitude of the two vectors should be equal to magnitude of the another vector. Then we can say that ABC are conical. I will be not solving this. You have to solve. Just let me explain it. Simple it is. Show that each of the given three vectors is a unit vector. You have to show this is a unit vector. What you have to do? Just take this as some vector, AB vector, or you consider as A vector, and this as B, and this as C vector. Then show that magnitude of A vector is equal to 1, magnitude of B vector is equal to 1, and magnitude of C vector is equal to 1. So that we can say that these three vectors are unit vectors. Next, one more question is there. Also show that they are mutually perpendicular each other. I mean, A vector is perpendicular to B vector and B vector is perpendicular to C vector. Also, C vector is perpendicular to A vector. That you have to show. What you have to do for that? Just take A vector, dot product of those, right? If it is the dot product of those is equal to 0, then we can say that those two vectors are mutually perpendicular, right? So angle between them will be 90 degree, cos 90 will be equal to 0. So by that, just you have to show A vector dot B vector is equal to 0. Then you have to show B vector dot C vector is equal to 0. Next, you have to show either C vector dot A vector or A vector dot C vector is equal to 0. How to find the scalar product or dot product? Just you need to find the dot product. You have to multiply each and every element and you have to add. Right? So this will be now 2 by 7 into 3 by 7 plus 3 by 7 into minus 6 by 7 plus 6 by 7 into 2 by 7. Add them, you will get that as 0. Similarly, you have to show B vector dot C vector and C vector dot A vector. Remember, dot product or the scalar product is nothing but just you are multiplying the coefficient of I cap, J cap and K cap, then you are adding. You are not supposed to write the vectors.